AOP that we studied in the previous chapter is the AOP that's been present in Spring since the start. One criticism of Spring's classic AOP support, it is verbose in the XML. I think we saw that in the previous chapter. So from Spring 2 onwards, they've really tried hard to make the AOP support both simpler and more expressive. So in this chapter, we'll have a look at the new AOP features from Spring 2 onwards. In this chapter, we're going to look at three topics. We're going to look at the Aspect J syntax, then we'll have a look at how to write your advice as plain old Java objects, and then we'll look at the new AOP namespace. So let's start with the Aspect J syntax. I briefly mentioned Aspect J in the previous chapter. This is another open source project completely independent of Spring that is a dedicated aspect-oriented programming framework. It's an incredibly powerful framework and goes far further than the Spring AOP. It does have a much steeper learning curve, however. But one thing that Aspect J have always had is a point cut syntax. Now, if you recall back to the previous chapter, what we had to do to set up a point cut was we had to configure a bean and provide a list of method names. And we also had to set up an auto proxy to make that point cut apply to more than one service object. So two big blocks of XML to achieve our point cut. In Aspect J, they have a syntax. So let's assume we want to set up the point cut along the lines of we want to apply advice to all methods in our service classes beginning with get. Well, what they can do is specify a single string. It looks something like this. I have to say this isn't actually correct yet. I'm going to build it up as I explain it. We can set up a single string, which is kind of like a wildcard really, and we're saying here look for all classes with the word service in the middle of them, followed by the method invocation of get something. And you can supply that to Aspect J, and Aspect J will then be able to do the appropriate weaving. From Spring 2 onwards, Spring have absorbed the same syntax. But what I have there doesn't really go a lot further than what I had in my XML. It's certainly going to be easier than writing that XML, but the beauty of this syntax is it goes far further than anything we had before. For example, we can specify that we want to apply advice to all the methods in the service classes beginning with get, but also accepting a string as the first parameter and then any other type for the second parameter. So I've specified this in those round brackets. Now you couldn't do anything like that in Spring 1's AOP support without writing code. And the flexibility continues. Let's say I want to do the same thing, but this time I don't care what the parameter list is. I specify that with two dots inside the round brackets. And it's not just the parameters going into the method as well. I can also discriminate based on the return types. So I could say, hey, look, I'm only interested in the methods that are returning collections. So I could specify the return type on the front as well. And this point cut syntax would say all methods in service classes beginning with get, but only those returning lists. And as always, I can use an asterisk as a wildcard here. So I've just replaced that list with a star, and now I'm saying return any type. Well, I have to admit that the expressions that I've showed you over the last couple of minutes won't actually compile. They're not quite true Aspect J point cut expressions because you also have to specify the phrase execution on the front, followed by round brackets. And that's because I want to apply this advice to all of these method executions. You might be a bit confused at this point because really everything we do in Spring AOP is based in some way around method execution. Well, in Aspect J, in the true Aspect J framework, you can do lots of other types of AOP, such as, for example, you can apply an advice to whenever you read an attribute. and not just when you call methods. So in the full aspect J syntax, there are other phrases you can put in place of the execution. But to be honest, in Spring AOP, not much of that is supported. So you'll almost always see this execution at the front of the phrase. Well, I hope that gives you the general idea of how to write these point cut expressions. In the Spring Framework reference manual, and I'm looking here at the online version, there are a list of examples of common point cut expressions. And do feel free to go and have a look at that. So what I'm going to do is I'm now going to take that expression and I'm going to show you how you would apply it to the code that we've been working on. Before we go into Eclipse, just show you how we hook this into the existing XML. And what I'll do is I'll take my existing point cut and I'm going to replace it with a new point cut. We use a class from the Spring Framework called AspectJExpressionPointCut. Very simple this time. We just plug in the expression that we're using to describe the point cut. Let's switch across to Eclipse and see this in action. So here's our code from the previous chapter and it's completely untouched. So just to remind you, we have our logging advice, or rather now it's more performance timing advice. There's our existing point cut, which we use this very clunky and old-fashioned Spring 1 name match method point cut. And I think the real problem with that is I also have to, if I can drop to the bottom, I also had to set an auto proxy up to tell Spring that I wanted that point cut to apply to all service classes. And then finally I had my advisor to wrap my advice and point cut together. You should have done a practical session on that by now and should be fairly familiar with it. So what I want to do is I want to retire this old-fashioned Spring 1 point cut and I'm going to upgrade it. So as we saw on the previous picture, what we're looking for is the AOP aspect J, and annoyingly all of the class names begin with the phrase aspect J in this package, which is quite a strange pattern. Aspect J expression point cut, and the property then is the expression that we're using, and for the value I just have to make up my aspect J expression. Syntax, so I'm looking for execution. Now I think I don't care about the return type, and I'm looking for all classes with the phrase service in them, any method invocation beginning with the phrase get, and I do not care what the parameters are. So there's a fully formed aspect J expression. Well, actually I have lied to you a little bit. Just for space I cut this down slightly. We also have to specify the package names as well because we are working with standard Java classes here. So this will be avalon.services. And so on. We can use wildcards for the packages as well, which proves to be quite useful over time. The other great thing about this form of point cut expressions is that in here we've specified the classes that we want to apply the aspect to as well. So we no longer need this, what I think is a bit of a bodge really. Before we just said, look, could you please auto proxy all of the bean names ending in service? Well, we can retire this completely now and we can say auto proxy all of the bean names. You'll find that there's a class in here called Default Auto Advisor Proxy Creator. Another big mouthful class name. It means that Spring will go through all of my beans and it will apply all point cuts that match that particular bean. So in my case, without any further config, it will find every service class and it will apply the advice to every get method. So that's another big advantage of using the aspect J expression syntax. I don't need that big clunky block at the bottom. I can just have that one line of XML. I can almost forget about that XML completely. So let's give this a try and see if it works. I'll just tell you that in my client application, I've just made a call to get entire catalogue. Now, I'm not going to hold the results, but I just want to fire that off to make sure that that gets advised. I've then called the get book by ISBN method, so I would expect to see that advised. The invoicing service is also going to be part of the advice captured by the point cut, but remember that we specified we only wanted the methods beginning with get, so we would expect to see raise invoice not be advised. So we'll give this a run, and oh dear, we have an exception. Let's have a look at what's going on here, and it will take a while to scan this. Oh, it's a no class def found error. Now this is because although all of this is built-in support in the Spring framework, it would have been ridiculous for the Spring team to write their own parsers to parse the expressions. So instead what they've done is they've just reused what's already there in aspect J. So you do need an aspect J jar file on your class path. And just retrieve my package explorer. So we have supplied in your lib directory for this chapter the aspectjweaver.jar file. You need to add that to your build path. I just want to mention it's a common misinterpretation here. Just because we have that jar file on the class path doesn't mean we're using aspect-j to do our AOP. We're not. We're using Spring. We're just using one small element of aspect-j. So hopefully that's fixed. Let's try it again. And this looks good. So I can see my timing advice on get entire catalogue and on get book by ISBN, but it's not there for raise invoice. But the real beauty is now you've got real expressive flexibility. Just by changing that expression now I can play around with where my advice is applied without having to deal with any XML at all. So for example, let's have a look at what we can do. We could, for instance, this asterisk here, recall, is saying we don't care what the return type is. Well, we could say that we want the return type to be lists, just list, and you will also have to supply the package name as well. So I'm only interested now in the methods that return lists because it may well be only the list returns are a performance problem. So let's give that one a run. That's excellent. You can see now that it's only applying the advice to get entire catalogue and it's not applying it to get book. Or I could do that the other way around, I suppose. I could say I'm only interested in the return type of book. Well, it's a common mistake that I make. I forget to put the package name in the front, so a little tedious, I guess, but now I would expect this advice to only be applied to when I call get book. And there you are, get book by ISBN, but now I'm not seeing it for the get entire catalogue. Another piece of syntax I haven't shown you is that you can say things like this. I could say, I'm only interested in the return type of java.util collection, but I'm also interested in any subclasses, and that's where the plus symbol comes in. So in this case, I would expect to see the advice to apply to the method that returns a list, and there's get entire catalogue fully advised. And finally, what I'd like to do, let me revert this back to all return types. We can also work at the package level here. We could say, well, let's say I'm interested in all methods in my service objects. The way I can do that is just to add a wildcard on the package level. So all classes in my services package, let me get rid of the get. We can make it literally every single method invocation in my service tier. This is a very good way of working. If you get your packages correct, you can be very precise about the AOP that you're applying. So I'd expect now to see the advice applied to all three method calls. And there we are. So get entire catalogue advised, get book by ISBN has been advised, and raise invoice has been advised. Oh, and before I forget, you can also specify ands and ors in your expressions as well. So let's say I'm also interested in advising my data package as well, or my deos. So I'll pretty much repeat the repeat the expression, but for my deo, or rather that would be avalon.deo.star for all classes, and then .star for all methods. And notice there I've used the OR symbol exactly the same as standard Java. Let's see if that one works. No, that doesn't seem to have made a difference. And I've just realized it's because my package isn't called deo, it's called data. So that's an interesting one. Notice that if no package is found, you're not going to get an error. You do get an error if there'd been no matches at all from the expression, which can be a little confusing when you're experimenting with this. That looks a lot better this time, so we can see all books, that's from my deo, get entire catalogs of service, find by ISBN is the deo, and so on. So really now this is limited by your imagination, and I'll remind you that the user guide on the Spring Framework website has an excellent set of examples that you can try. We'll now look at how we can use the AOP schema to make your AOP more simple in the XML. To enable the AOP schema, we need to add the following two lines to your schema definition at the top of your XML, and this will only work in Spring 2. Now, of course, I haven't memorized that. I'm working here from the user guide at springframework.org, and the lines that you need to add are there. So what's the purpose of using this schema? Well, there's two benefits of using the schema. First of all, the auto-proxying is going to be a lot easier than it was, and secondly, it will enable you to write POJO advice. So let's have a look at this. Back in Eclipse, you'll remember that to set up auto-proxying, I had to remember a rather clunky, long class name. And it's a rather strange class in that I don't give it an ID, I just create an instance of it, and that will automatically make the auto-proxying work. Well, if you're using the AOP namespace, then it's much simpler. I can lose that entire line. I don't have to remember that class name anymore. Now all I have to do to enable auto-proxying is to refer to the AOP aspect J auto proxy, and it's just an empty tag. There's nothing more to remember, and that's all I need, assuming that I have some advice configured in my XML and that there are point cuts matching some of my beans. You'll see that now the advice is automatically applied, and I think that's rather sweet. The second thing I can do with the AOP namespace is use plain old Java objects for my advice. Recall previously, to write some advice, for instance, here's my around advice for my performance timer, you have to implement a particular interface, and it doesn't matter whether you're writing before, after, or around advice, you have to implement an interface with a specific method. Now that's usually okay, it's not a particularly difficult interface to implement as you've seen. But the problem might come with what if I have a class that's already written and I have some standard plain old Java methods in there and I want to use them as pieces of advice. Well, this new namespace allows me to do so. As an example, I've already created a class called POJO advice. In real life, I'd give that a much more meaningful name. It's just for an example. The point I want to make is it really is a complete plain old Java object. There's nothing special in there at all. I just happen to have a method in there, and I could have called this method absolutely anything I like. Just to prove that, I'll change it to, I don't know, something very bland and generic like do something. So this could be a class that I wrote 4 or 5 years ago, and for some reason I want to use it now as a piece of advice. Let's have a look at how we can do that using this new namespace. The first step is, as normal, I need to create an instance of my advice class, and that's what I've done with the first bean. I'm going to call it POJO advice. To make that POJO become a piece of advice, I'm using the AOP config tag. I can put in here all of the AOP configuration for my application. Inside is a series of aspects. I only have one at the moment, but I can add more in later. The AOP aspect tag is pointing to the POJO advice that I've just created. And then inside there, I declare what type of advice this is going to be. And here I can specify before, after, around, and so on. And then the rest of it, I hope anyway, is fairly self-explanatory. I'm specifying the method that I want to invoke, followed by the point cut that I'm applying, so that will define when this aspect is going to run. And just with that tag in place, and assuming that I have the auto proxy tag in place as well, that's all I need to do to make a POJO become a piece of advice. I hope you'll agree that that's quite a bit simpler than all of that creating advisors and point cut objects and wrapping them all together. Well, of course we need to see if this works, so let's switch across to Eclipse, and here is our advice bean. I haven't yet set up the AOP config tag, so it's AOP config, and assuming your environment has been configured with the Spring IDE, adding these tags in becomes really simple indeed. AOP colon aspects, and then I'm going to specify AOP, let's make it some before advice. And oh, I've just forgot to put the reference to the actual advice in there. And in here we specify the method that we want to run. And that's great, means I don't have to have a particular interface. And I also specify the point cut that I want to apply this to. So let's say our point cut is going to be any return type, and then any method in com.inceptiontraining.avalon.services. We'll make this absolutely any class, any method with any set of parameters. I think that's a valid point cut. So now I'm no expert at writing these AOP config tags, but you can see that that just took about a minute to set an entire piece of advice up with no need to create any intermediate objects. Well, that's okay only if it works. So let's just think about what we expect to happen here. I've applied this advice to all of my service methods, and the advice I've applied is this plain old Java method here called do something. So we'd expect to see it just say now at the start of the method. Well, we'll give that a run. And that looks like it's working. I can certainly see it firing off. Don't forget I've also got my timing advice in there as well. So that's yet another way of doing AOP in Spring, and providing you're working on Spring 2, that's another choice for you to make. Which technique do you prefer? Now there is a problem with this plain old Java object advice, and that is, remember, before we could access information such as the method, the target method that's being called, and the arguments that have been passed into the method. Well, of course, since this is a plain old Java object that has no connection with AOP at all, we can't get that anymore. If you do need to get at those pieces of information, then you can completely optionally add in a parameter to your advice method. Now, of course, this does mean it ceases to become a plain old Java object, but it still means you don't have to implement a particular interface, so it's still more flexible. What you do is you add in the parameter called join point. We can call it anything we like, and the import is from the Aspect.J framework. That is actually from the jar file that we added earlier. Now, what can we do with this join point class? Well, that really just gives us access to all of the things that we had in the previous way of writing advice. So, for instance, I can get access to the arguments array. I can find out the target object that we're heading for. And if you want to know which method is being called, then what you're looking for is the getSignature method. The getSignature method will give you information such as the name of the method, the modifiers of the method, and so on. So if I wanted to make my logging actually reflect what the method has been invoked is, I would just say jp.getSignature.getSignature get name. So let's give that a run and make sure that works. And there you are. You can see now the method names are being output onto the console. So okay, this is not a Pojo anymore, but I still have the advantage in the XML that the configuration of this is, I think, a lot simpler and cleaner than the XML configuration that we used before with the advisors and actually creating a separate object for the point cut and so on. So what I'd like to do to close this session on the AOP namespace is upgrade my existing performance advice to use this namespace instead. So recall what we have at the moment. We've created this piece of advice called performance timing advice. I've created a point cut object to apply that advice to particular methods. And then finally I had to create an advisor to wrap the advice and the point cut together. What I'm going to do is retire these two beans here, and instead I'm going to use this AOP config. So I'm going to say this is a new aspect, and this is now going to be a round for my performing, and method equals, well, at the moment, if I go back to my performance timing advice, this is the old-fashioned way of doing it where I'm implementing a particular interface, and the interface, remember, was always called invoke. I can carry on calling it invoke if I like, but as with this AOP namespace, we don't have to implement a particular interface anymore. I can call this method anything I like, and I think it makes sense to give it a more meaningful name. Now in this case the method is timing an invocation, so I'm going to call the method time invocation and just sort the import out there. I'm going to need to make a couple more changes to this, but back into the XML, my method is called time invocation, and I'll also specify my point cut, and as usual it's going to be something like, I think we'll apply it once again to all of the service methods, so I'm going to have the same point cut as before. Forgive my terrible typing, I'm actually sat behind a microphone here so it's quite hard to get to the keyboard. And there we are. And that one simple tag has replaced those two big heavy beans that I had before. Oh, and I've just forgotten to specify the reference to the actual advice that we're pointing to. Recall in our previous work for a round advice, you're passed in an object of type method invocation, and you use that object to proceed to the target when you're ready to do so, and you also use that object to find information about the method. You're actually passed an object from a different class when you're using the AOP namespace, and this class is called proceeding join point. And the difference is, as you'll see when I do the imports, this import comes from the Aspect J framework. Now this proceeding join point actually looks and feels pretty much like the object that we had before, the method invocation. There's a proceed method on there to proceed to the target, so that's the same as before. In order to get the method's name, it's almost the same. We call get signature followed by get name. So very little to change, it's just a slightly annoying thing that you have to remember. And by the way, you get an absolutely horrible error if you forget to do that. Well, hopefully that's all in place then. Looking back to my XML, a very simple, almost one line of XML to apply this advice. I'll just run that. And excellent, we can see the timing advice applied absolutely perfectly to our service classes. Another thing I really like about using this namespace is it does encourage me to put all of my AOP config for an entire application into this single AOP config tag. I've worked on projects before where they have AOP scattered all over the place, And using the Spring 1 version, it's very difficult to see where the AOP actually is because it sort of gets lost amongst all of your other beans. So I think this is a much more focused way of applying your AOP. Just occurs to me there's one final improvement I can make. Have you noticed that my point cut here is the same as my point cut here? You'll see that a fair bit, that you want to apply the same point cut again and again and again. Well, what I can do is I can factor that point cut out into a single point cut and then reuse it across the entire application. I'm using here the AOP point cut tag, and what I do is I give the point cut a name, and I'm going to call it all service methods, and then we specify the expression, and I think I'm justified here in doing a little copying and pasting. So that's my point cut defined, if I can get the quote marks sorted out. And the great thing now is I can refer to that point cut throughout my entire application, and I do it by specifying point cut ref equals, and then I just refer to the ID of the point cut, and I would do the same thing here. I can use that anywhere I like, and naturally if I now change the point cut, then that would reflect all the way through the code. Just one check to make sure that works, and there we go. You now have two ways of configuring your AOP in Spring. You have what could be called the classic AOP support, which has been around since Spring 1, where you have to manually create lots of beans, such as the point cut bean and the advisor bean, and you have to wire them together correctly. But from Spring 2 onwards, we have this much cleaner AOP namespace. There is a third approach. I have to be completely honest here and say I don't personally like this approach. But as always in Spring, the choice is yours. You might love this approach. So I'm just going to close the AOP chapter by showing you this final approach. You may well be aware that XML is becoming very unfashionable in Java, and there's a large move over to annotations. In Spring 2, you can use annotations for your AOP instead of XML. The benefit of this, if you like annotations, is that you can completely retire all of this AOP config. So the immediate benefit is going to be much simpler XML. If I get rid of that, all that remains, and you do still need this one line, is the auto proxying. Well, of course, we have to configure the AOP somehow, and as I've said, it's going to be via annotations. Let's go back into our performance timing advice class. This is how it was before, pretty much a plain old Java object. Instead of the XML, we can use Java 5 annotations. The annotation we're looking for is you annotate the class with the aspect annotation, and you annotate the method with the appropriate annotation of before, after, or around. I'll need to import those annotations. And the around annotation isn't compiling yet because what I also need to supply in here is the point cut. And to supply a point cut, I find this very strange, very unintuitive. What you do is you just declare a method and it returns void, and you can call it anything you like, and what you're looking for here is a readable name that makes sense to the point cut. So if my point cut is for all service methods, then I will call this method all service methods, and you leave the method body blank. You are never going to call this method. It's really just a tag or a marker method. And the idea is we can annotate that method with the point cut annotation, and then in here you just specify as a string the point cut. So for us it will be our old friend the execution star followed by the package of services, and I'm going for all classes, all methods, and any arguments, exactly the same point cut as before. If I just arrange the inputs, I think that will now compile. And then what you do in the around annotation is you specify the name of the point cut that you're applying, so all service methods. So that's how it hangs together. But those three annotations have just replaced all of the XML that I had before. Let me just remind you, I'm finished with this class now. I'll just remind you that in the XML, I now have no AOP at all, apart from I have to instantiate the advice object and I have to apply the auto proxying. If I give this a run, you will see, oh, I have an exception. Let's just work out what that is. So point cut is not well formed. Oh, I've made a mess of my point cuts. So I'll go back into my advice class. Oh, it just looks like I've missed a round bracket from the end. Well done if you spotted that one. See if that's cleaned up the problem. Oh, and I've just realised that you also need the round brackets on there as well. So it's a fairly strange syntax, but once you have it, all should be well. And there we are, we can see the advice applied as before. So I think arguably in terms of configuration, this is the cleanest way of applying AOP. As I say, it really is just a personal prejudice that I have against it, because now the configuration of the AOP is compiled into the code, meaning that if I need to change the point cuts, I have to go in here and recompile. I prefer to have that kind of thing out in the XML to make the configuration of it more flexible. But as always, the choice is yours. Annotations are a third way of applying AOP and certainly result in a lot less XML. In this chapter, we've seen how Spring 2's AOP support has been dramatically improved. Using the AspectJ syntax, we can define point cuts far more effectively than before. Also, we can write our advice in the form of plain old Java objects without the need for lots of complicated XML configuration. And finally, you can also specify your advice using annotations, which almost completely cuts out the XML. And you'll be practicing with all of these features in the practical work. In the next chapter, we'll be showing you how AOP is used to support automatic transaction management. We'll see you then.